486 CPU inside it. And it's playing the music. All right, folks, we're going to get to listen to a talk called Dirty Tricks using nginx and Lua to thwart bots and script kiddies. And Eirik Øverby will give the talk. So, enough said for me. Here we go. Thank you, Eirik.
Hello, everyone. I just want to be clear, I did not make this music. I just have the computer. That's all. I'm just showing off other people's work here. I'm here because I felt like I needed to find something that would combine my retro computing craze with something that might look like work. So let's see how this works. So, hello everyone. I'll admit right away that I have given this talk sort of like this once before at the EuroBSDCon last year. It was all sorts of fun, even more exciting than here in, getting the video and everything to work. So, let's see. I'm going to talk about nginx, which is very appropriate for this hardware, obviously. I'm going to talk a bit about Lua in nginx. Now, before anyone gets any ideas, I'm not an expert on either, but you can do some cool things with it. So, I have tried to come up with a way to use this to help protect against certain types of garbage on the internet. Basically, I have a couple of other old machines. One of them is running a BBS, if anyone remembers what that is. If you don't, it's basically a dial-in system predating the internet by a fair bit, at least the web. You would have a modem, you would dial in, and you would have your session. And if the BBS only had one modem, you would be the only one there until you hung up and the next person called in. It's great fun. Problem is, a 386 machine running a BBS from 1992 or 3 is not going to fare well if you expose it to the internet and allow people to telnet into it, because then you'll have all the Nmap scans of the world just hammering it to death. It takes 10 seconds to spin up a connection, and by that time you had 5 others trying to make the connection. So, of course, I mean, why would you even do anything with this? Like creating a CAPTCHA for telnet. That would seem an appropriate question, because I use Lua for work as well, a little bit. I'm old enough to be nostalgic about these things. And the internet is, as we know, all hunky-dory and otherwise a bad place. I couldn't find any prior art on this, specifically the telnet CAPTCHA part. And I can, as it turns out. But talk to me later if you want to hear about the prior art thing. It has some wrinkles in that story. So, who am I? I spoke to some of you throughout the conference. I am a sysadmin. Turns out I've been a sysadmin since I was around 10. I mostly play with FreeBSD, work and privately, except obviously on this machine. For work, we do payment authentications. So if you have a card and you pay anything online, there's a fairly good likelihood to hit our systems when you're asked to authenticate. Again, FreeBSD, open source and all that, which is fun. I'm fighting for open source in every way I possibly can. Trying to cling to the fun parts of it, hence FreeBSD. Also, I like to make my life harder. By night, I dabble in retro computing. I hoard hardware, I have been told, and walking into my office would sort of prove the point, I guess. I have been told I'm a performance artist, as in making old hardware do silly things. Some of you got my business card from the Floppy Museum. I'm running a web server and an RAC server and some other stuff on a 286 machine in the office, which is kind of fun. I love Sierra and LucasArts games, drinking beer, and my Roland MT32 is very dear to me, for anyone who knows what that is. I'm a father of 4 in a slightly untraditional family. It doesn't fit in the Apple family concept, so we have some trouble with that, and you know, other things, but I manage my cats. My plan, as far as it goes, I want to help take the internet back from corporations, and I've heard that from so many people here, both people giving talks and people that talk in the audience, so it feels a bit like being home. I love it. I love learning about alternative solutions to what people think are the only way of doing things. That usually involves breaking up the monocultures. We're back on the FreeBSD as well. And to just have as much fun as I can. And then, of course, I run BSD. I also run DOS, a fair amount of it. And because I'm properly weird, I also run a bunch of OS2. Woo! If anyone remembers that. A bit of my talk is about this whole celebrating the act of rediscovery. We used to tell computers what to do. You got a computer, it literally had a prompt asking you, what do you want me to do, right? Now we have a menu. We have some icons. We have a some set actions that the computer allows us to do. We can't really do much ourselves on many of the devices that we own. And lifting the hood to understand what's going on has become a lot harder. Again, something that more people have been speaking about, and I'm sure I'm preaching to a choir, but it bears saying again and again. And nobody learns, at least very few people learn anything because they have to. It's great that you learn stuff because you're interested in it. It's great that you maybe attend a good course or have good colleagues at work, or you happen to be at a great university, but being given a tool and then be forced to figure out how to use this tool, and not to mention what you can use it for, is largely a lost art. Of course, you have some who really want to do that, and I bow before them because I had to learn. Anyone who now chooses to learn the hard way are better people than I am. So, a few words about my dad and his friends. They collected and fixed old cars and motorcycles. This is why I have a motorcycle license, driving license, because I enjoyed that. I was a part of it, but I didn't really quite understand it. They complained so much about modern vehicles. They had their old Java motorcycle, or their old BMW, or their own Norwegian Tempo. It was like ridiculous bikes, but come on, you could take them apart and put them back together in a day, and they might even run afterwards. Our kids will never understand, right? At least that's what my dad thought. I understand a little bit now, but it took a while. And they knew how to do this, and they learned how to do it because they had to. Also because it was possible, obviously, but they had to learn how to fix their cars. They couldn't take the car to a garage, a workshop, every time something broke down. There was no money for that, and also you might not even get there. And then you have me and my friends, not that unlike. We collect and fix old computers, right? Where's the difference? We complain about modern computers. I can spend all day doing that. And my kids will certainly never understand. I have failed horribly. Maybe they will later. I'm probably not going to be alive to see it. And some of us, at least, we used to do this because we had to. We bought computers in parts. We were fixing computers. There wasn't the same availability of pre-made computers of every shape and form as you have today. You bought parts according either to your budget or your need. And then you assembled it. And then maybe you even programmed it, if you're even a bit older than I am. Yeah, you can try and read this. I am not pretending this is not a midlife crisis. It can take many shapes, and it can involve wheels or heels or eBay deals, and either way it costs the same. But I was going to talk about, protecting and denial of service and stuff like that. And this is why. This is the welcome screen of my BBS. Now, I have made a horrible mistake. I was going to demo this, and I've forgotten to ask for an Ethernet cable. So I can't actually do that, and I'm very, very sorry. But this is what it looks like when you log in. It's technically a 386 class machine, despite saying 486 over there. It's running Synchronet, which was a fairly popular BBS software back in the early 90s. It runs on OS 2, because of course one does that. It has a couple of virtual COM ports, serial ports, that are managed by a piece of software running on that machine that will accept telnet connections and hand those connections to the BBS software as if it is a ring signal from a Hayes modem. And this is software that was written in the mid-90s. It works, but it doesn't like the internet very much. Because the problem is that 386 class computer. Now, it accepts the telnet connections, it emulates a modem, and does all these things. And best case scenario, you have an Nmap scan that causes a ring and run situation. And then it takes half a minute to recover from that. So it drains resources. It's a proper denial of service. And worst case, it will just crash because it's never been exposed to any of it. Nobody, threw an AI at this to find vulnerabilities, and nobody ever will. If I have anything to say about it. But don't diss the 386. It is a fantastic CPU. I absolutely love it. They can do so many things. I have a 286, which is like not even the little brother. It's like a embarrassing shadow of the 386, and yet I have a web server on it running the floppy museum, and it was on Hacker News, and it survived 90,000 hits in a few hours. It was a sight to behold. And I wasn't even around. Someone messaged me and told me, dude, do you know what your floppy museum is doing? The 386 is quite powerful. It has virtualization. Somewhat primitive by today's standards, but it can do a lot of cool stuff. It has unlimited virtual memory. Come on, 4 gigabytes. Who needs more? It can actually multitask. You can do many things at the same time on that. Well, technically you can task switch, but it helps you do it. Protecting the memory and having, all these atomic operations and stuff. But what I'm doing here, you probably don't want to do it at home. Maybe please don't. But on the other hand, who am I to tell you? We're down to the nginx config. I don't know how many of you want to spend time reading this. You can also find the slides online. What I'm doing for my telnet captcha is using the stream module in nginx. This is basically just a TCP proxy. It will accept a connection, make a connection to a backend, and forward packets. The tiny little extra thing I'm doing here is using Lua to keep track of whether or not you have actually passed the challenge that I'm about to present. And a couple of other housekeeping tasks, like for example, making sure that I don't send too many connections in at the same time. That's why I have a maximum of 2, because I have 2 virtual modems on that thing. There's an external file with the actual challenge. I'll show you that later. And you just maintain a counter of attempts and users and so on. Here's basically the important parts of the captcha. Because nginx has already set up the connection for me. Someone telneted to the box, and I can, send bytes on that connection. So I print out like hello and all that. And they generate a couple of numbers, and I ask, okay, what's this plus that? And then I wait for some data. Because I haven't bothered implementing a full telnet protocol, I just stay in the single digits. So that it's not a hard quiz or anything. But Nmap can't answer it, so that's basically what I went for. I pull the result, and then obviously I check if the answer was correct. I drop the connection if it's not. Otherwise, the connection is simply passed on to the upstream, to the actual BBS. And yeah, as I said, most of the magic is in the Lua code. I'm using Lua at work for some fairly trivial tasks, so it's been enough to tell me that it is very, very powerful. You can do a lot of cool things with it, and I have some ideas that I've been told not to talk about, but I will anyway. nginx does much of the heavy lifting. It does all the session setup. It can make sure you don't overload your backend, some things like that. And if anyone did this before me, the telnet proxy thing, I would really like to meet that person. I'm fairly sure this is a first. You can use it in anger or in self-defense, as the case may be. And this is when I was supposed to demo this. I can try and get that going after the talk, please forgive me. And that's why I have to run part 2 right away. Yeah, great demo, huh? Say what?
He didn't fail.
Yeah, he didn't fail, that's true. How about something useful? So, I was thinking, how can I turn this into something that might be more relevant to normal people, like all of you? Let's say you have a site. You want to add some trivial protections to prevent it from, being completely overloaded by scrapers or what have you. We set aside a bit of memory to keep track of in-flight sessions. We first define a location saying this is where my actual website lives. We check if we have a valid session. We set some maximum age on a cookie or something, and then you pass the request to the backend. But when people land on your site for the first time, they usually hit the root, right? The slash, just nothing, no path, no nothing. And that's where I pull in some Lua to create this session, but also perhaps do some rate limiting or something like that. So you set this initial header, you set a cookie, and then you redirect to the actual content you have. But then in the session create part, you can, for example, take some of the data from the session you have, like the IP address, the user agent string, and stuff like that, and then you just create a session key out of these things, which will usually be somewhat unique. I mean, even the scrapers, they don't usually all come from the same IP. But this is a very, very simple example. There are ways to make this actually useful. And then when the user comes back in, you check that the remote address and the agent and all these things still match. And then if they don't, you redirect them back to the root so you can generate a new session token. And of course, that's when you can use nginx's own rate limiting, for example, to keep this from happening too often. Point is to keep people away from your dynamic website, which you have on the /my site, and just handle everything with this static content, which is a lot faster than invoking your application every time. As I have learned at work, the moment an attacker manages to even tickle the application, we have lost. Then you can just go home, basically. Does it work? Yeah. Been using this both for the BBS, it sort of works. and for real live stuff, it definitely works. Largely the whole thing about the session management, you make sure you spend a little time to set up the session, and then you force as much work as possible on the client before you actually accept the request to your website. It has some severe limitations, of course. You still might want to use something like Anubis or a different tool of the same ilk to, protect against scrapers and that sort of thing. But this will work with any web client that supports redirects and cookies, which even browsers on OS 2 will happily do. A couple of other ideas. This is fairly dirty. You can pick up the initial connection during the SSL client hello. So before your nginx and your CPU or whatever you're using has, spent several watts doing TLS, or if you're on a slow computer, you really don't want to do it a lot. You look at the properties of the client hello message. Particularly interesting is the SNI, the server name indicator, which is basically a way for a client to tell your server before the certificate is presented by the server that I want to access this site. It's like virtual hosts back in the day. It allows you to present the correct certificate for that request. Which also means that all this happens before any actual cryptography is taking place. So we pick that up and we do something with it, like for example we match it against something we know we're going to get, or some other magic. So you want to avoid cookies and skip the TLS handshakes when things are out of whack. Put your session ID in the host name. Use a wildcard DNS record for your domain, and instead of redirecting to another path on the same host, you redirect to a random host name, which basically means you can check the session ID during the TLS handshake. Wildcard DNS, you make sure that the random host names you generate are DNS compliant. That's not hard to do. And then you can send people off with a 302 to that new temporary URL and do all sorts of things like rate limiting there. And trust me, this has a massive impact. If you want to be extra efficient and you don't even want to have that initial connection to create the session ID, you can get it from elsewhere. For example, you can, I wonder if I wrote that here? Hold on. You can, for example, have some tiny snippet of code running somewhere else that just does that initial thing, generating this random host name and sending the 302 back. Maybe you even use some cloud or something for that. Keep it off your system where you want to save resources. Then you will only actually get the redirects with the random host names, and then you can verify them. You can also punish bots by making them wait on the TLS handshake without actually spending any CPU. Okay, you may want to watch your concurrent sessions and all these things, but you can still do a lot without burning any CPU. And when you're getting 300,000 TLS requests per second, saving CPU helps. Take my word for it. You can also send them off to some kind of target, or something I've been playing with is you drop the connection on the floor if they're using an invalid session ID. You drop the connection so hard you don't even send a reset or a fin, which means the other end thinks they still have a connection and they sit there waiting, but your system is happily closed down the socket and didn't do anything. No work, no loss, no resources drained, almost none anyway. And really, those scrapers, this is from last year when this was a huge problem. I know it's still a problem for a lot of people. I wish they would just go away. So what is all this good for? I don't know. Quoting a movie here, point, see if you can guess. You're still going to do a lot of TLS if you're protecting against scrapers and whatnot, because most people, most others than me, don't have websites on HTTP anymore. And that initial connection can still cost you a lot. But if you don't need to invoke your application for it, you're still saving a lot of time. You can do this little session setup and everything in nginx, in Lua, and you don't have to bother your application, which is probably where you have least resources available. And this is something that was mentioned to me a year and a half ago when I did a similar talk, not this one, a more modern talk, on denial of service attacks. We need client-side proof of work when setting up a TLS connection. So if the browser or the agent or whatever crap it is tries to talk to you and you already struggle, you're already sweating, your CPU is already maxed out, you can tell it through the server hello that, hey, you need to slow down, you need to solve this puzzle before we'll allow you to continue the handshake. I thought this sounded like a great idea, and there's actually standards body work going on. There are some guys in Holland, because where else, working on this right now. It's probably going to take years, because you still need support for this in browsers and such. But from the last I heard, even Google are looking at getting this into Chrome at some point. And as we all know, if they do it, everyone does it, and then live happily ever after. So I'm pretty much at the end. The slides are available there. You can get them in several forms. You can get them as ANSI files for the draw, which is the tool I'm using. You can get them as PDFs, boot is, etc. Or you can download a floppy disk image, which is a bootable floppy with the whole talk and a web server and an IRC client. So you can connect to my IRC server, which runs on my floppy museum, and tell me how cool this talk was. You're very welcome to do so, of course.
How do you read the floppy disk?
That's your problem. I have been told that the image is bootable in stuff like QEMU or whatever. And I have had people visit me on the IRC server from their QEMU booted floppy.
You can use 86 box.
86 box, yes, I've used that actually. It will work in 86 box. I wonder what else I have. Not much, I think. Thanks for having me. I have so much time, I might even want to try and connect this thing to the BBS.
We have questions, so
Please.
let me pass the mic to Pandey.
Neil, I should have started the front line again.
So, the idea that you have of using different subdomains in order to try to authenticate systems, it's really good, but how can you handle the privacy problems that entails? I mean, there's basically two options. Either you use TLS 1.3 and then the SMI information is encrypted, and then you need to perform cryptography in order to be able to access it. Or you use TLS 1.2 or 1.3 without the encrypted SMI extension, in which case it's possible for anybody passively listening to connections to identify different users and at least make navigation patterns, even if they set the same IP address and so on.
You wouldn't really see the navigation patterns because you only see the host name. I mean, I understand what you're saying, and I know this is not useful for every case. The case that we've been using it for at work is basically you have a transaction-oriented system. And then before actually doing any processing on the transaction, you set up the session and make sure that you can't replay or reuse that address in an attack. Because sometimes it's enough to simply rate limit on that host name. The value is unique, sure. It doesn't in itself give anything away. And generally it will be short-lived. If you have a different setup, you can also use it as a bridge into established sessions using a different mechanism. But no solution is perfect, and it won't work in every scenario, obviously. But feel free to talk to me after. I'm really interested in hearing thoughts about it, because I've only considered this in my bubble, my silo of problems, right? There are so many others.
A question that is not related to a talk, but to floppies.
Oh.
I assume they are not produced anymore. And I heard recently that in about 5 years, the world is going to run out of new old stock. What will happen then? Are we okay?
I don't know. Have you asked your doctor? No, seriously, even in Norway, I think, even now, floppies are being used by doctors' offices and stuff. This is, it's a bit embarrassing. I saw recently some chatter about someone manufacturing floppies at home from scratch, which is much like all the other stuff we're doing in retro computing, right? You have so many tools and so many technologies available to you now that you can do things that was unthinkable 20 years ago. At home. The sound card that was playing back the music you heard in the beginning is made this year. Okay, it has old chips and components, and it perfectly, it looks exactly like one of the old ones, but you have so many of those that are broken in some way. They've been through, I don't know, run over by trucks or what have you. So that people have now the tools they need to very cheaply and quickly produce new PCBs and to transplant this stuff. Same with the production of floppies. I'm sure if the need is great enough, someone's going to sort it out. Until then, I have a few hundred floppies in my office. If you know anyone who's willing to pay top dollar, I might consider it.
Now when we're into retro computing, and not for your talk, I was wondering what you think about picogas and, for example, for Amiga, so you can put Raspberry Pi, PiStorm, and what do you think about all different new extensions? For C64, there's 1541 Ultimate, so you emulate to disk drives, not just in general.
First of all, what do you mean this is not a retro computing talk? The next stuff was just my excuse to get in here.
That was a dirty trick.
Yeah, that's my dirty trick indeed. I own a couple of picogases and some other hardware in the same category. I can understand the people who think this is not proper. On the other hand, it makes the whole experience, I mean, this machine without some of that new hardware would be far less interesting and much harder to get back up and running. For example, one of the nostalgia things I do not miss is spinning rust. So in this thing there's no spinning rust. There's a tiny little disc-on module thing connected straight to the motherboard ID plug. And yes, on the one hand it's cheating, on the other hand it's not the problem I'm trying to solve for. I'm trying to learn how the systems work. Whether it's a spinning drive or not doesn't really matter. But you will have different opinions on this. You have the picogas, you have the Pico IDE that is coming out soon, which is an absolute marvel of a project. You have the Pico Mem, which is just a tiny little 8-bit ESA card that will do everything under the sun, expand your memory, give you a hard disk, floppy images, an NE 2000 Wi-Fi card. I mean, come on. Of course this is cool. It depends what you're going for, what experience you want.
Hi, last year I gave a talk at the Linux kernel conference, and I reminded people of back in the day, 25 years ago, when we were using Linux on floppies as a safe router, because you couldn't buy boxes. So there was a specific distribution called Linux Router Project, where you could boot it from a 720K floppy and run a whole firewall and some at least mail server proxying on the disk. And that's made people gasp, but that was actually a route to all the embedded Linuxes if you looked at the lineage later. So the things they did to make it boot on a 720K floppy was actually important work, the constraints they solved the problem under, to later do embedded Linux.
I love that. So brilliant. Trying to operate under these sort of constraints, like the floppy museum site. Yeah, it runs on a 286. The whole thing, including operating system and web server, IRC server, FTP server, and BBS, microscopic, granted, but still. And the client for the Novell NetWare server, where I have the files for the BBS. You know, all these things fits on one floppy. Cheated a little, so it's like 1.8 megs on it, but it's incredible what you can do in that amount of space, which makes, you know, certain software projects nowadays look kind of embarrassing.
Should we talk recapping afterwards?
Sure.
I don't know what recapping is, but it seems like if you could understand these small systems, if you're able to...
Replacing old capacitors in the web computers so they can run again.
So they don't explode in your face.
Yes.
Ah. Okay. Sounds scary.
So the hardware batteries don't leak.
Please.
Ugh.
I've done the puff of smoke thing, but never anything like that. But it seems, does it help you that you can reason about these smaller systems because you can understand more of the system, given that they're smaller? And, yeah. Does that help you in your work today? Does it help you reason about computers or programming language?
It makes me an old man that yells at cloud. I mean, yes, it helped. What I like, one of the many things I like about the old computers and everything is that you can look at it, inspect what it does, and actually truly understand what's going on. Nothing is kept from you. I mean, maybe they tried by not releasing documentation to everyone, but at the end of the day, it's a pretty one-to-one process. Once you move into the Pentium Pro especially and onwards, you start having all these microcode layers that are much harder to figure out. But on this thing, given the time and patience, I could debug pretty much anything on this machine. Or someone who actually knew what they were doing could do that. I could tell them what to fix, and then, you know, it would help me out, hopefully. So that is, in a way, it's a bit inspiring. I want to tell a tiny story about when I got started on this retro computing stuff, which is not long enough ago, honestly. I had gotten this 386 machine, and I wanted to boot DOS on it. I had nothing, but I went to a store around the corner, and they had USB floppy drives, amazingly. So I got one of those, and I had some floppies, and I made a bootable DOS floppy. Then I went home because I had kids to pick up and blah blah. Come back the next day to the office, the power has gone out in the meantime. So my computer has rebooted, and it's asking me for the date and time, which is what DOS does if you haven't done anything but, you know, making a system disk. This is a 64-core AMD Threadripper machine. Why does it boot DOS from a floppy? Why is this possible in 2020, whatever it was? There's no wonder our machines are gobbling energy like there's no tomorrow. So that is a contrast that can say a lot.
Okay, well, the conversation can continue, but I think we're at the end of our time here, run over a little bit, I think. So thank you so much, this was wonderful.
Thank you for having me.